Professor Ken Dawson is Chair of Physical Chemistry within the UCD School of Chemistry and Chemical Biology. His research focuses on groundbreaking nanoscience projects, exploring biointeractions, nanorisk and nanomedicine.
The general feeling of people that are close to this field is that it's a revolution, a technological revolution, not unlike what happened in the Industrial Revolution, when people really began first to use machines to make things. It just changed the world. And so that's the kind of technological revolution I think that we're looking at here. Nanoscience is a science of very, very small things. I think you know what a millimeter is. It's a very, very small distance that you sometimes can see on a ruler. So it's very small. Now imagine 1,000,000 times less than that. That is a nanometer. So what nanoscience is really about is engineering, fabricating objects on that size scale. Most of us have a mobile phone, computers. They work at a certain speed and they eat up a certain amount of energy. Now imagine building all of these devices smaller and smaller and smaller. Well, the electrons have to travel only shorter distances, and so they don't cause as much heat. It means they don't need as much power to push them along, which means they consume less electricity. Nanoscience is going to make things work faster, consume less energy. These are the sort of things that we really need to be doing at the minute. We think it's actually going to be durable science, something that will contribute to our society and our economy for decades to come. So we're no longer thinking about individual projects as much, but more about building a critical mass in Ireland that can really reach out, contribute to, and affect the situation globally in this whole field of research.
So, how will this field of research be relevant to the search for sustainable development?
So this is the hard edge of where our achievements as scientists meet our responsibilities to the future. I'm breathing billions of very, very small particles. And over decades, we've learned to limit and control the numbers of particles so that we no longer endanger ourselves as we did, for example, in London in the 1950s, where many people died because of the dust pollution. So as the years have gone on, we've learned to undo the risks that new technologies bring to us. Here we have the opportunity from the beginning, before it's implemented, to actually look for the potential hazards. So it's not important only to look at how nanoparticles interact with people, but it's important to understand how they interact with the environment. If we damage the environment, it might be something we can't reverse. The full potential for nanoscience, we don't really appreciate it yet. I don't think that we even know where the boundaries lie. But my guess at the minute is that the limits are in our imagination and not in the technology.